Hello friends, welcome back to my classroom. In this lecture, let us derive mean and variance of both binomial and Poisson distributions. So, we have already discussed in our previous lecture that the probability mass function of binomial distribution will be ncx p power x q power n minus x. And also, we had noted that mean of binomial distribution will be n multiplied by p. So, n is the number of trials and p is the probability of success in one trial. So, if you multiply n and p, you will get the mean of the binomial distribution. And also, variance can be found just by multiplying n, p and q. And in case of Poisson distribution, where PMF is mu power x e power minus mu divided by x factorial, the mean will be mu itself. Whatever mu we are using here, the same mu will be the mean, and also variance will also be equal to mu. So in this class we will prove these things, that mean of binomial will be np, variance will be npq, and for Poisson, mean and variance both will be mu. So let us take the case of binomial distribution first, and as a prerequisite, let us recall binomial theorem, what we have learnt in our high school. So binomial theorem, as per binomial theorem, the expansion of a plus b whole to the power n for any integer n, a plus b whole to the power n is nc0 a power 0 b power n plus nc1 a power 1 b power n minus 1. We are just increasing the powers of a and decreasing the power of b. So next it will be nc2 a power 2 b power n minus 2, and so on, and the last term will be ncn a power n and b power n minus n. So if you simplify this, we will be having a plus b whole power n is equal to nc naught is 1 for any n. So a power 0 is also 1. So first term we will have just b power n, and nc1 is n for any n, and we have a power 1 and b power n minus 1 with that n, and nc2 is n multiplied by 1 lesser than that, n into n minus 1, and it will be divided by 2 factorial. This will be the value of nc2 for any n, and a power 2 b power n minus 2. If you consider the next term, it's going to be n into n minus 1 into n minus 2 divided by 3 factorial. The nc3 will be, and it will be multiplied by a power 3 into b power n minus 2, and so on, and last term ncn will be 1 for any n, and a power n, and b power 0, b power n minus n is 0, so b power 0 is also 1. So this will be the expansion of a plus b whole power n. So just keeping this in our mind, let us try to derive mean of binomial distribution. So I'll take binomial distribution, and for binomial distribution we know that p of x is ncx p power x q power n minus x. So our first job is to prove that mean of binomial distribution will be n into p. So let me start with general formula to find the mean. Mean formula is summation x multiplied by p of x, x running from 0 to n. So, and p of x is ncx p power x q power n minus x. This is the value of p of x for any x in case of binomial distribution. So now x is running from 0 to n. Let me expand that summation. So let me start with 0. So when I put x equal to 0, since this x is present here, in place of x I am writing 0, and whatever may be the value of this is going to be 0. So first term will be 0 plus the next value of x is 1. So when I put 1 in place of x, so 1 nc1 p power 1 q power n minus 1 plus the next value for x will be 2. So it is 2 nc2 p power 2 q power n minus 2. And one more term if you consider, it's 3 multiplied by nc3 p power 3 q power n minus 3 and so on, and the last term will be x equal to n. So n multiplied by ncn p power n multiplied by q power n minus n. And I'll just write the values of these combinations nc1, nc2, nc3, all these things. See, idea is very simple. Once you expand this, you just simplify, give the write the values of nc1, nc2, nc3 and all, and whatever terms possible, you try to cancel them and just see for the common term and try to take the common out. So I'll take the I'll not consider this first term where 0 is there. The next term I'll be taking it as my first term. 1 is there, okay. nc1 value is n, and we have p power 1 q power n minus 1 plus 2 times nc2. nc2 is n into n minus 1 divided by 2 factorial p power 2 q power n minus 2 plus 3 into nc3 is n into n minus 1 into n minus 2 divided by 3 factorial p power 3 q power n minus 3. So if you consider the next term, it's going to be 4 times n into n minus 1 into n minus 2 into one more term will be there, n minus 3 divided by 4 factorial. So I'll just ignore it. I'll take only these many terms plus last term will be n into ncn is 1 p power n and q power n minus n is 0. So q power 0 is 1. So as I already mentioned, I'll try to cancel whatever terms possible. 2 factorial means 2 into 1. So 2 factorial can be cut with 2. And 3 factorial means 3 into 2 into 1. So 3 can be cut. You will be left with 2 into 1. And in the next step, you will be left with 3 into 2 into 1 when you cancel 4 and 4. And observe carefully for the common term. In every term, n is common. And not only n, p is also common. Q is not common because q is not present in the last term. So only n and p are common. So what I'll do is I'll take out n and p. So once you take out n and p, you are left with q power n minus 1 in the first term plus in the second term n has gone out. So you have only n minus 1 divided by 1, which can be written as 1 factorial. And out of p square you have taken 1p out. So you are left with p and q power n minus 2 plus n is not there, only you have n minus 1, n minus 2 divided by 3 has been cancelled, so you have 2 into 1 only. This 2 into 1 is there, which is 2 factorial and p power 2 now q power n minus 3 plus, and in the last term n is not there, n is outside and 1p has gone. So out of p power n, 1p if I have taken out, I'll be left with n minus 1. So, and now this np into whatever is inside my square bracket, if you observe it carefully, that is binomial expansion of p plus q whole power n minus 1. Okay, so if you want, you can just check what is the expansion of a plus b whole power n. It's starting with b power n and n into n minus 1 by 2 factorial, like that coefficients are going, and a power is getting increased in every step, b power is getting decreased. So you can compare that with our uh, expansion what is there in the bracket. Instead of a and b, we have p and q here, and the highest power there it was n, and here it is n minus 1. So what will happen? This will be n into p multiplied by p plus q whole power n minus 1. And what is p plus q? P plus q is, let me write it to the left of this. You can observe here. We know that q is 1 minus p. So in binomial distribution, ncx p power x q power n minus x, once we know the value of p, we used to calculate q with the help of this only. Q is 1 minus p. P is the probability of success and q is the probability of failure. So q is just the complement of p. So since q equal to 1 minus p, the same equation implies that p plus q is equal to 1. If you take minus p to the left hand side, it is plus p. So p plus q is equal to 1. So since p plus q is equal to 1, 1 to the power of n minus 1 is also 1. So 1 to the power any number is 1. So these two are, you have in the final step n p multiplied by 1. So you will be left with only n into p. So that's the proof. Very simple proof, which shows that mean of binomial distribution is n into p. So very easily you can prove this. What you have to do is just take the general formula of mean, expand it by giving the values of x, and after that try to take out whatever common is there. So n and p will be common. Once you take common terms outside, you will be left with p plus q power n minus 1, which is actually 1. So that shows that mean of binomial distribution is np. So hope you understood how to derive the mean of binomial distribution, and very easily you can do that. So I'll go to the next proof, which is variance. And variance, I have to prove that it is n into p into q. So what I'll do, uh, take the I'll take the general formula of variance to start. So variance is summation of x square p of x minus mu square, x running from 0 to n. So in this case, instead of directly expanding, before actually expanding this summation, I'll just make some adjustments. So what is to be done is, to this x square whatever is there, I'll just subtract x from that, and again add x there. So it will remain x square only. There will not be any change. So multiplied by p of x is there, minus mu square is there. So once I have done this adjustment, idea is just separate these two as one summation and remaining x as the other one. So what will happen? This will be equal to summation x from 0 to n x square minus x. This I am separating it. X square minus x, and it is multiplied by p of x. Plus, for the remaining x, I'll write it separately, 0 to n x p of x. So one summation I have made it as 2 by separating x square minus x and x. And what is left? Minus mu square is left. Okay. And in the next step, I will take x common from this x square minus x. X into x minus 1, p of x. And please observe carefully this term, summation of x into p of x. So this is just the mean, the general formula for mean, summation x into p of x. So what will happen? I mean, this is mean, so I can write it as plus mu instead of that summation, and minus mu square. Okay. And after this step, I'll start expanding, like giving the values for x. So first, when I give the value x equal to 0, so since this x is present here, this will be 0, 0 into anything, that's 0, plus when I give the value, the next value of x, 1. So 1 when I give, here 1 minus 1 is there, x minus 1 is there in the second, in the bracket. So 1 minus 1 will give you 0 into anything is again 0. So first two terms will be zeros. Now when I give x equal to 2, it will not be 0. So x is 2 multiplied by 2 minus 1 into p of 1. Oh, you would have you could have written ncx p power x into q power n minus x in place of p of x in this step itself, or you can do it later also. Okay. And when you give x equal to 3, this will be 3 into 3 minus 1 p of 2, plus next term will be 4 into 4 minus 1 into p of, oh sorry, did I miss something? Yeah, sorry. So this is not p of 1, this is not p of 2, this is not, okay. So this will be p of 2, this is going to be p of 3, 3 into 3 minus 1, x into x minus 1 into p of x. So 3 into 3 minus 1 into p of 3, 4 into 4 minus 1 into p of 4, and so on. And when x value is n, it is n into n minus 1 into p of n. And after all these steps, I'll just add mu and subtract mu square, plus mu minus mu square is there. So our variance is going to be, or okay, 2 into 1 into p of 1, p of 2, plus 3 into 2 into p of 3, plus 4 into 3 into p of 4, and so on, n into n minus 1 into p of n, plus mu minus mu square. Okay. So let me take it to the next slide. So what is variance? Variance is 2 into 1 into p of 2, plus 3 into 2 into p of 3, and 4 into 3 into p of 4, and so on up to n into n minus 1 into p of n, plus mu minus mu square. Now let me replace this p's, p of 2, p of 3, p of 4, etc. by their mass function. So 2 into 1, and just to recall, I'll write it here. What is mass function? P of x is ncx p power x into q power n minus x. Okay. So what is p of 2 then? In case if I put x equal to 2, it will be nc2 p power 2 q power n minus 2. And 3 into 2 is there, p of 3, x is 3 now. So nc3 p power 3 q power n minus 3, plus 4 into 3 into nc4 p power 4 q power n minus 4, and so on, n into n minus 1 into ncn p power n, q power n minus n is 0. So plus mu minus mu square. And let us try to simplify this. So variance will be equal to 2 into 1, and nc2, already we have discussed, nc2 is n into n minus 1 by 2 factorial, p square q power n minus 2, plus 3 into 2, nc3 is n into n minus 1 into n minus 2 divided by 3 factorial, p cube q power n minus 3 plus 4 into 3 into nc4, which is n minus 1, n minus 2, n minus 3 divided by 4 factorial into p power 4 q power n minus 4 plus and so on up to n into n minus 1. N is 1 and you have only p power n plus mu minus mu square. So like we did in case of mean, let us try to cancel some terms. So this 2 into 1 will get cancelled with 2 factorial. So you will be left with 1 here. And 3 factorial is 3 to 1. So 3 into 2 will get cancelled. You will be left with 1 factorial here. 4 factorial is 4 into 3 into 2 into 1. So 4 into 3 will get cancelled and you will be left with 2 into 1. And once this is done, I look for the common terms. So what is common here? N is common everywhere, n minus 1 is also common everywhere, and p is also there. Okay, except these two terms I am talking about, last two terms where mu minus mu square are there. Okay, so n minus 1 and p minimum power of p is 2. So p square also can be taken as common. So n I will take common, n minus 1 I will take common, p square also I will take common. So once you take these three common, you will be left with what? Let us see term by term. First term. In the first term, q power n minus 2 is left. Plus, in the second term, n has gone, n minus 1 gone. So you will have n minus 2 divided by 1 factorial into p power 3. But out of p power 3, p power 2 is outside. So p power 1 will be there. Q power n minus 3. Plus, n and n minus 1 are not there. You have n minus 2, n minus 3 divided by 2 factorial. P power 2, q power n minus 4. And so on. And in the last term, you have n minus 1, p power 2 has gone out. So you have out of p power n, I have to remove 2 power 2. So you have p power n minus 2. So that once that is done, you just have to not to forget this mu and minus mu square. Okay. And now if you observe carefully, whatever I have written in the floor bracket, it is binomial expansion of p plus q whole power n minus 2. Okay. Just to recall what is binomial, here it is there. So a plus b whole power n is this, there it is, instead of a plus b, it is p plus q. And power n here and there it is power n minus 2. Okay, so you can observe that and you can write this as n into n minus 1 into p power 2 and this is p plus q whole power n minus 2. Of course, you know that p plus q is 1. So 1 power n minus 2, it is again 1 plus mu minus mu square. So now this will be equal to n into n minus 1 into p square and p plus q is 1. So 1 power n minus 2 is gone. And now I'll replace mu and minus mu square by their mean. We are talking about binomial distribution and we have already proved that mean is np in binomial distribution. So mu square will be n square p square. So what will happen here? I have plus np and minus n square p square. Now we are left with just some cancellation and our proof will be ready. So let me do it here itself just by opening the bracket. N into n, n square minus n into p square plus np minus n square p square. So further, if I open the bracket and take p square also inside, so it is n square p square minus np square plus np minus n square p square. And good news that n square p square is getting cancelled. Now you are left with np minus np square. np minus np square. Let me take it to the rich board. So np minus np square. So variance is np minus np square. So again, I'll take the common term out. N and p are common. So once I take n and p out, I am left with 1 minus p. And what is n minus p? 1 minus p is q. So this proves that variance is np q. Okay. So both are very simple. The idea is expansion and taking the common terms out, and you'll be left with an expansion, expansion where binomial theorem will help you to simplify it. Okay. So now uh, we since we have proved that mean is np and variance is npq, variance symbol is actually sigma square. So variance is npq. So once we have the binomial distribution, we know the values of n and p. We need not use general formula to find the mean and variance. Very quickly we can calculate. Say for example, my binomial distribution is p of x is equal to uh, 5cx 0.3 power x into 0.7 power 5 minus x. So I need not expand this. I need not use the general formula to find the mean and variance. Very easily I can identify that n is 5 and p is 0.3. So mean will be 5 into 0.3. So which is 1.5. And further, if you want variance, you just have to calculate what is 5 into 0.3 into 0.7, which is q. And standard deviation, of course, is the square root of variance. Okay, so hope you are clear with this. So now we will move on, and we will try to prove the that for Poisson distribution, mean will be mu and variance will also be same. So let me take the case of Poisson distribution now. Poisson distribution. So for Poisson distribution, we have the PMF mu power x e power minus mu divided by x factorial. And we will prove that variance and mean both are mu. Idea is same. The steps are same. Whatever you did for binomial, you will do the same thing for Poisson also. But as a prerequisite, here what you have to recall is the Maclaurin series expansion of e power x. So the Maclaurin series expansion of e power x is 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial and so on up to infinity. So this is the Maclaurin series expansion that you would have studied in your lower semesters. So e power x is this. Okay. So remembering this, we'll now start the proof for mean and variance of Poisson distribution. So let me start with the general formula as we did in case of binomial. Mean is summation x into p of x, x running from 0 to infinity. So in case of binomial, we restrict ourselves to n. Here n we let tend to infinity, as Poisson distribution is more appropriate for big n's, and it is valid probability distribution only when you allow n to infinity. So mean is this. So we will replace p of x here, 0 to infinity x, and in case of binomial we replace p of x by ncx p power x q power n minus x, but here we replace it by mu power x e power minus mu divided by x factorial. In fact, this proof is easier than theorem, binomial distributions proof, because there we use binomial theorem, which is here we use Maclaurin's series expansion, which looks very simpler than binomial expansion. So let us start expanding this by giving x values one by one. First, when I put x equal to 0, you can observe that x is there in place of x. When you put 0, the term will become 0. 0 into anything is 0, so first term will be 0. Plus, when you put x equal to 1, this will be 1 mu power 1 e power minus mu divided by 1 factorial, plus 2 into mu square e power minus mu divided by 2 factorial, plus when I give x equal to 3, it is 3 mu power 3 e power minus mu divided by 3 factorial, plus, okay, one more let me write just for better understanding, 4 mu power 4 e power minus mu divided by 4 factorial, and goes up to infinity. And what will happen here, mu and okay, before taking the common terms out, or let me take the common terms out, mu is common here and e power minus mu is also common. So once I take out both these things, in the first term I will be left with 1. In the second term, what's happening? 2 and 2 factorial, they are getting cancelled. Mu and e power minus mu are out, so you are left with mu. Plus, here you have to observe that in the numerator 3 is there, in the denominator 3 factorial is there. 3 factorial means 3 into 2 into 1. So I can cut 3. And in the next term 4 factorial means 4 into 3 into 2 into 1. So 4 will get cancelled, you will be left with 3 into 2 into 1. So this will be mu cube is there. So mu you have taken out, so you are left with mu square, and e power mu minus mu is already outside. And in the denominator you will be left with 2 into 1, which is 2 factorial. And in the first term you could write it as 1 factorial. And in the next term mu power 4, so mu is outside, so you will be left with mu cube. And in the denominator you can observe that it is 3 into 2 into 1, which I have written it in red pen, 3 into 2 into 1, so it is 3 factorial. It goes up to infinity. And now what is left in the inside this bracket is Maclaurin series expansion of e power mu. Okay, e power x expansion is this. So in place of x we have mu. That's the only difference. So this will be mu e power minus mu and e power mu. So e power mu and e power minus mu will get cancelled, and that proves that mean is equal to mu. So for both binomial and Poisson, the steps are same, just the difference is there we use NCX p power x q power n minus x, and the expansion will be binomial. Here p of x is mu power x e power minus mu divided by x factorial, and expansion is Maclaurin's. Okay, so moving on, now we will try to prove that variance is also mu itself. So let me start with the general formula for variance. Variance, which is denoted by sigma square, the general formula is summation x square p of x minus mu square, x running from 0 to infinity. So let me start expanding this. Okay, before expanding, as I have already told you, an extra step, x square has to be subtracted by x and added by x again. P of x minus mu square, x running from 0 to infinity. And this separation of these two, x square minus x has one term, summation x square minus x p of x as one term, plus summation x p of x as the second term. X square minus x is separated, x square minus x separated, and this x is in this term, xp of x. So x running from 0 to infinity, x running from 0 to infinity minus mu square. And now I'll take x common from this, so I'll be left with x minus 1 P of x running from 0 to infinity, plus this is the mean, formula for mean, so this is going to be mu minus mu square. So once this step we arrived at this step, I'll start expansion. So I'll give the values for x one by one. First value for x is 0, so this term is going to be 0. Second value for x is 1. When you put 1 also, this is going to be 0. So because 1 into 1 minus 1 into p of 1. So this 1 minus 1 is going to be 0. So it starts only when x becomes 2. So 2 into 2 minus 1 is 1 into p of 1, plus 3 into 3 minus 1 is 2 into, oh sorry, again I missed it. This is not p of 1, this is p of 2. X value we are putting. This is going to be p of 3. 4 into 3 into p of 4, plus 5 into 4 into p of 5, and so on up to infinity, plus mu minus mu square. So let me replace this piece by the probability mass function mu power x e power minus mu divided by x factorial. P of x is this. P of x is this. So I will replace x by 2 in the first term, x by 3 in the second term, x by 4 in the third term, and so on. So this will be 2 into 1, p of 2. P of 2 means mu power 2 e power minus mu divided by 2 factorial, plus 3 into 2, p of 3. P of 3 means mu power 3 e power minus mu divided by 3 factorial, plus 4 into 3, p of 4. P of 4 means mu power 4 e power minus mu divided by 4 factorial, and so on, plus mu minus mu square. So let us uh, observe what is common and what can be cancelled. So let me cancel the terms here as many as possible. 2 into 1 has gone with 2 factorial. 3 into 2 also will go with 3 factorial. Both these will be 1, which can be written as 1 factorial. And only here 4 factorial is actually 4, 3, 2, 1. From which 4, 3 will get cancelled and you will be left with 2 factorial. So what will be the expansion? Let me complete it here itself. So variance is equal to, in all these terms you can observe that mu square is common and e power minus mu is also common. Mu square and e power minus mu, if you take it out, you will be left with 1 plus, in this mu cube, mu square has gone out, so you will be left with mu. And in the next term, mu square is there because mu power 4, 2 has gone out, so 2 will be left. But divided by 2 factorial is there. And in the next term, it will be mu cube by 3 factorial. So this can be written as 1 factorial up to infinity. And after that, plus mu minus mu square. And as we have already discussed, mu square e power minus mu, and this summation is Maclaurin series expansion of e power mu, plus mu minus mu square. Now what can be done? Now this e power mu and e power minus mu has gone, so you are left with mu square plus mu minus mu square, and at last you can cancel mu square minus mu square, and you will be left with the proof that variance is mu. Okay, so mean and variance both are mu itself in case of Poisson distribution. So suppose I have this Poisson distribution, p of x is equal to 9 power x e power minus 9 divided by x factorial. Then we can directly take the mean as 9, variance as 9, and standard deviation will be square root of 9, which is 3. Okay, hope you understood how to derive the mean and variance of both binomial and Poisson distributions. Okay, thank you.